Hi everyone. In today's video, I want you all to take some object which has a linear dimension. I have taken this scale. You can take a pencil, you can take a normal plastic scale or something which has a linear dimension. It could be a rod also. Now what you need to do is perform this activity with me. Put your fingers, two fingers below the rod or the scale and try to bring the fingers close so that they touch each other. Let's see what happens as I do it. You can see only one finger move till now. Now the other finger is moving and again one is moving, then other one is moving. At times both are moving and they meet here. So to understand what just happened, we need to know two simple things about forces in physics. The first is what I call the normal force and the second is friction. Now normal force comes when two objects will press each other. Okay, so for example, imagine this is a block and it is resting on the surface of a table. Now you all know gravity is trying to pull this block down, but the block is not going down. Why? Because the table is supporting the block. Now how the table is supporting the block? By exerting a force on the block upward. So that is the only way gravitational force can be balanced. Okay, so if the gravitational force is down, the normal force has to be up. Then only the total force on the block will be zero. Then only the block can be at rest. So this is what we call the normal force. So this is the normal force on the block by the table. I hope you will realize the more you press, okay, the more you press, the more will be the normal force. So it is basically what I say is pressing force. Let's come to friction now. Suppose you have an object here like this and you try to move the object by pushing it this side. This is your push. Now you may realize that if your push is very small, the body is not going to move. You can try it with your almirah or your table. Try to push it by applying little force. The body may not move. Now why is that happening? The only way that can happen is if there is a force in the opposite direction which will balance this force, right? And that force has to be from the ground, from the floor, and that is what we call frictional force. So it is this frictional force which keeps the body at rest, and such a friction we call it static friction. Static friction. So this means if you have a block and you push by applying some force, let's say 1 unit, any unit, and the block is still at rest, then it means there must be an opposite force exactly equal to this one so that it will cancel each other, right? So the total force on this is 0 because these two are in opposite direction. So if this is plus 1, this should be taken minus 1, so total force will be 0, and that's why the block is at rest. Come to this now. So if I increase the push from 1 to 3, let's say, and the block is still at rest, then it means the friction also has to increase from 1 to 3 in order to keep the block at rest. But the friction, which I call the static friction because it keeps the body at rest. Static means rest. So that static friction has a maximum value. Let's assume the maximum value is 3. So up to this point, when your applied force is 3, static friction can also increase up to 3 and it will try to keep the body at rest. However, if your push becomes more than 3, 3.1 let's say, then the body now cannot be at rest because the static friction which keeps the body at rest, okay, it increases maximum value up to 3 I have assumed. So once I apply 3 more than 3, 3.1, the block will move. And once it moves, the friction which comes is what we call kinetic friction. So we saw that if the maximum static friction is 3 units, then your push has to be more than that, then only the body will move, right? Now look at these two diagrams. If I ask you in which one more pressing is going on between the block and the floor, then obviously the answer is in the second case there is more pressing going on than in the first case. Why? Because there is a person sitting here, so obviously because of his weight more pressing will be here than here. And in the first part I have explained to you that the more is the pressing, the more will be the normal force. So here the normal force is greater than here. Keep that in mind. Now if I ask you in which case you will need more force to start the motion, again obviously the answer is second case, because here there is more pressing, you will need more force here to start the motion. Now that means what? That means the maximum friction here which tries to stop your applied force, which tries to oppose your applied force, that friction obviously here is more than here. That means one very important thing we have realized, and that is the maximum friction static, remember, is proportional to this normal force, or you can say the pressing force. So wherever there is more pressing force, there you will also have more maximum static friction, which means you will need more force to start the motion in the second case than in the first case. Now observe this diagram. Imagine this is some kind of a rod and I am putting my finger here, applying this push N1, and you are keeping your finger near the end and you are applying a push N2. Now if I ask you in which case more pressing is there between this finger and the rod or this finger and the rod, then the answer is here more pressing will be there because you are near the center. So N1 is greater than N2. So having understood the physics, let us now apply it in our demonstration to understand what happened. So when you keep your fingers on the scale like this, one finger will be always little bit more towards the center than the other finger, right? So let's assume, let me keep it this way. So you can see the first finger is much nearer to the center than the second finger. So let's say this is the first finger, second finger. So the first finger is more near to the center, which means from whatever we have learned, there more will be the normal or pressing force. Therefore, here there will be more friction. Therefore, when I try to move, this will be at rest because friction is more. So other one will move. Let us check. As I try to move, this one will move, right? So wherever friction is less. After some time, that will come more near to the center. Then other one will start moving now. Did you see that? Now this is coming much nearer to the center. So here friction will be more. So now other one will move. Right? Again, so this is how the friction at the two places keep changing depending on which finger is more near the center. And whichever finger is more near the center, their pressing will be more, friction will be more. So that finger will stay at rest, other finger will start coming towards the center till that other finger comes nearer to the center than the first finger. Then what happens? Then in that finger now friction will be more. So now that will be at rest and the first one will start moving towards the center. And this will continue till both of them will meet at the center. Right?